Hi, welcome to Think Human. I'm Chris, and in this video I want to talk about how did we discover black holes. So black holes are something that came out of Einstein's theory of relativity. This is something that he did not set out to look for. Black holes wasn't his intention to create into the world, while Einstein wanted this to describe the universe in a better way, this kind of galaxies and stars, massive objects in the universe, like how do they work better, and how space and time is connected, and gravity and mass and energy, how these things are connected. So black holes only are as a consequence of these theories, like artifacts of these theories. And so for decades people wondered if these are indeed some kind of side effect of the theory, or do these things, something so crazy, really exist truly in our actual universe. So about 100 years later, well, exactly 100 years later, Einstein's general theory of relativity was in 1915, and we detected the gravitational waves in 2015. So kind of poetic, interesting coincidence. So how we discovered them? We discovered them by gravitational waves, and these are exactly the kind of gravitational waves that we would expect to find if we were to see two black holes colliding exactly the same signature. And how we detected them? We built research facilities in US, and two of them, and kilometers and kilometers, thousands of miles apart, to get accurate measurements, to make sure that both get them relatively at the same time. And so they did it. They made a big tunnel and essentially had a laser that shoots light through it. And as gravitational waves pass through space and time, they kind of expand and contract the space and time. And while these lasers go through to the end of the tunnel, the detectors, they can measure this kind of disturbance in space and time, and indeed they did find it, and the exact signature as something as gravitational waves that have been traveling for billions of years just to get to our detectors and for us to discover it. So um, this is concrete, definite evidence of black holes. There is nothing else that could make anything like this. These are definitely black holes. A little bit later now, they discovered the merge of gravitational waves from two neutron stars, and what's crazy about them is that they could actually see it as well, not just detect the waves, but it's 100% that it must be something as massive as a black hole colliding, creating these waves, and it's truly incredible. But that for 100 years, no one had any idea. No one really even predicted or wanted these things to exist. They were just kind of a funny thought, as a funny figment of imagination, as kind of something that just fell off from the theory. But now, indeed, this has been confirmed to be the case, and this is really in physics, in the world, what you want. You want to have a theory and something to come out from that that you didn't look out to, kind of. If you, in other words, if you see something in the world and your theory can explain it, and you didn't make the theory to explain it, then you have a good theory if it explains many things as well. So this is definitely good and shows us that Einstein's theory of relativity is correct one to describe space and time in large scales. Of course, it's not the ultimate theory, and this is for some other time to talk about, because gravity doesn't, we don't know any way of actually describing these same objects, these black holes, what happens in the middle of them, the singularity, the gravitational singularity. By these equations are told to have infinite density, and in physics, in natural sciences, no one is happy about infinities, because you have to quantify something. It can't be literally infinite, or can it? Well, that's a philosophical question, whatever. But yeah, so there must be some other theory to explain more precisely what happens in the really, really smaller scales in very massive objects. So gravity together, that usually works in really large scales, and then quantum effects, something on really tiny scales. So how these two can work together. Some proposals of string theory, and some other loop quantum gravity, things like this. Now I'm talking about string theory, but essentially, yes, this is how they discovered black holes, by gravitational waves. Incredible achievement for Einstein, for everyone, for science, for humanity, to find these kind of things and actual proof of it. And I have a video about black holes as well, if you're in any way interested, and I hope you got something interesting out of this video. Thank you so much for watching, and take care.